From mysterious constants to playful patterns, step into a world where every digit has a secret. We are going to discover the secret of two numbers 9 and 11 in this particular video. Now, this video is part of our new book, which is inspired by math. Now, it's an inspiration from our mathematician, and here in particular, we are celebrating Kaprekar. He loved these numbers, and we'll do Kaprekar's way to solve this particular question. So the problem here is find the value of n to satisfy the criteria for divisibility. So A is n 123 is divisible by 9, and part B is 6174 Kaprekar's constant followed by n is divisible by 11. How do we do such a question? Now, the rule for divisibility by 9 is that the digit sum should be equal to 9, right? So, digit sum means sum of all the digits, right? In the simple plain language. So, let's do part A first. So, we are trying to figure out that n plus 1 plus 2 plus 3 should be equal to 9. Only then this number will be divisible by 9. Okay, so that gives us n plus 1 plus 2 is 3, 3 plus 3 is 6, equals to 9. So we get the value of n. The value 3 can satisfy this. Now senior students could do 9 minus 6, right? The book is really for junior and middle school students, so we'll follow step by step the way they think, and they will be solving this particular problem. So n plus 6 is 9, means n should be 3, right? Not much to think about, and therefore the number here is 3123, right? So that's the first part. We got the value of n, which is 3. Now, in addition to this, it's worthwhile to check if this number is really divisible by 9 or not, right? So, in addition to what we have done, let's figure this out. We'll follow long division now and divide our new number 3123 by 9. So 31 can go into 9, and that should be what? 9 times 3 is 27, right? So if we take away, we get 11 take away 7 as 4, bring down 2. 9 times 4 is 36, and 9 times 5 is 45. So 9 times 4 can work. 9 times 4 is 36, remainder being 12 minus 6 as 6, and bring down 3, 63. So the number 7 evens it out. Perfect. So you can see that the number 3123 is evenly divisible by 9. So what we did was perfectly fine. The digit sum should have been 9. We worked it out, got our answer. Now let's do part B on a fresh page. There you go. Correct. So this time we have a number which is 6174. It is also called Kaprekar's constant, but it is followed by n, and we want this to be divisible by 11. What is the rule for divisibility by 11? Well, it is that alternate sum of the digits, when you subtract them, then it should be a multiple of 11. Slightly confusing, right? What basically it means that if you add these numbers and if you add these numbers and subtract them from one another, then whatever you get should be a multiple of 11. Right. That's what it means. So alternate sum of digits and their difference is multiple of 11. Now easy way to do is something like this. So we'll begin with 6, and what we'll do, one by one subtract the next one, right? Minus, and then we'll do plus 7. You get the whole idea. Minus 4 and plus n. Do you see that? we work this way out. This is a simple approach which is taught to us by Kaprekar. You see how simple it is? Basically, we are adding 6, 7, and n, and from that sum, we're taking away the sum of 1 and 4. That looks familiar to you, right? As being taught, correct. But this is a much neater approach to get to the solution. Perfect. Let's figure this out. 6 minus 1 is 5. 5 plus 7 is 12. 12 minus 4 is 8. So we want that 8 plus n should be equal to what? Multiple of 11. Okay, multiple of 11. So what should be n? 8 plus 3 is 11. Okay, that means n equals to 3. So we get our answer. N this time also is 3 for us. Great. And so it's time to verify. Perfect. Let's do it. We have our number which is 6174, also known as Kaprekar's constant. Watch our video to understand why it is called Kaprekar's constant. And then n we figured out is 3. We're going to divide this number by 11. Perfect. So 11 division should not be so difficult. 5 times will give us 55. And when you take away 11, take away 5 is 6. We get 67. 6 gives us 66. 14. 1. 11. 33. And you get 3. Perfect. So we could evenly divide the number 61743 with 11. And what did we get? We got 5613 with remainder as 0. I did not write that, right? When you multiply by 3, you get minus 33, and that will give you 0. Perfect. Did you like this approach? Straightforward. So, Kaprekar gave us lot of numbers which are famous by his name, right? He is an entertainment mathematician. What we are going to do in this book is to go beyond school curriculums and understand what math is. So this is more than math. It's a playground of patterns. Discover more in Inspired by Math. Thank you. Register for our workshops at our website globalmathinstitute.com. Thank you.